Hey YouTube, it's JP Dillon. This is a 1957 General Electric 14-inch black and white all-metal portable TV. And it's in okay shape. It's got some dings and scratches here. The cover here has a bit of a abrasion that we see if we can take care of. This is owned by the same customer that I did the Predictive Princess for. He's into a lot of vintage electronics, including televisions, and he likes to display them, so the purpose of this series of videos is going to be to troubleshoot and get this set working. This set has not been turned on. We don't know its condition. However, he did include a parts unit with a good CRT and an operating chassis, although operation is really considered turning on and producing a blank raster, but it's there in case we need it. Now this one had a very weak CRT with a brightener on it, and it rejuvenated okay, but the parts unit has a perfectly good CRT with no brightener, so we're probably going to end up swapping it. Well, let's take a look inside. As you can see, it's got quite a bit of rust and corrosion everywhere. It's not very pretty. And there's our brightener there, the cap of which fell off. Yep, so that's just kind of what it is there. Not sure if that's a replacement yoke or not. It doesn't look like the factory one, but I could be full of it. So these are very compact. They're not very fun to work on. They generate some heat, and they kind of bake. And it's a 14 QP4A that's in here, and this one still has an ion trap in it. So that definitely kind of puts it as the original. I think the other one didn't, but I'm not certain. But anyways, what we're going to do today is kind of do the brief checks, see if it's got, a usable high voltage rectifier, horizontal output, and damper, and just kind of use a dim bulb tester on it and see if we can get it to fire off, because he's not turned this one on yet. And then we can kind of gauge what condition the chassis is in. And although we're going to be pulling this, I may use the other chassis because this one's kind of rough looking, and I would rather start off with a good chassis to restore than one that's going to take a lot more effort. So let's yank the high voltage cover open and see what the flyback looks like and such. And usually to get inside of here, you just squeeze these little clips like this. And there's our high voltage rectifier. It's a good sign there's no wax strippings or anything like that. See if we can kind of get this out of the way. It's a little awkward now that it's fallen apart. But there's your filament booster right there. It's like a 1 to 1.2 or something, some kind of ratio like that. Just cram it back in here. So if you ever wondered what's inside of one of these, that's pretty much what it is. Then there's our horizontal output. There's our damper. Got some nice asbestos covered wiring there. So let's go ahead and see if we can get this rectifier out. Because there's no point in powering up if the rectifier is no good, because you're not going to get any high voltage to the set. This is a 1X2B. Problem is, I don't think I have any of those. This is probably like a 6BQ6 or something. That's gone to air. So we don't need to test that one. We know it's bad. And our damper's a 12AX4. So series set. All right. Now, obviously, I'm not going to be using this. Curious what this actually is. Replacement too. It's a silver tone. So this was changed at some point, but obviously it's gone to air. We can't use it. So I'll probably be taking the replacement out of the parts unit. And the only purpose of this is just to see if the chassis can work on its own. So let's get the tube checker out and see what condition the dampener and the high voltage rectifier is in. Alright, so looking at our damper, that's pretty straightforward. Heater 12, plate 13, socket 18. So let's plug it into socket 18 here. And let's see if our damper's any good. Lighten up at least. Yeah, it's coming around. Yeah. Not great, but it should be good enough for a test. Okay. So that's that. Now let's look up our 1X2. Alright, so that's a little more complicated. That's socket 29. So that's going to be this guy over here. Plates 34. Yeah, let's see. The only two we got here are A and B for the filament. Really? A and B for the filament. Everything else goes down. 1 volt. And then what are we using for the, that's the Y pin, which is right there. Let's see if our high voltage rectifier has anything to say. Now we're not going to be able to see the filament because it's only a 1 volt filament. And let's see here. No short. Good emission though. That's happy. So let's go pluck the horizontal output out of the donor machine and pop it in here, and then we'll stick this on a dim bulb tester and see what it does. So here's the inside of the donor, which you can see used to be the same color as that one, but somebody repainted it with what looks like house paint. Not sure why they did that. This one's also got an ion trap on it. Same looking yoke, so I guess that is the factory yoke. Here's our horizontal out. And this set we know works. $12DQ6. Alright. I'm not even going to bother testing this one since we know that this parts chassis turns on. But this chassis, although dusty, at least doesn't have any corrosion on it. It's very clean looking. So, depending on what the overall condition of that is, I may just swap chassis. They are the same thing. Although, in this is the Hot Point version, which is, I think, the T14 or something like that. Anyways, yeah, let's pop the tubes in and see what happens. Alright, so we know the rectifier is good. I'm just going to pop this one back in here. Assuming that I can get the key correct. There's very little room to work in this cage. So it's probably going to take me a bit to get this up in here. Alright, there's our rectifier. Now these little wires and stuff are fragile as hell, so don't bend and twist them if you don't have to. And here's our dusty horizontal output tube. I'm just going to leave the dust on there for effect. I'm going to leave the top cap off until we know that our power supply is stable. And there's our damper. And since this is a series string, all the filaments have to work. Alright, so let's get a cheater cord and a light bulb and see what happens when we apply power. Alright, so we got our cheater cord in. We have it hooked up to our isolation transformer through this 100-watt bulb. We're going to clicky the power. And we're going to see what happens. Bulb's getting a little dimmer, not much. But I do see filaments lighting. You see the horizontal output tube lighting up down there. So that's a really good thing. And it's getting a little dimmer. So that's good. That tells us that there isn't a hard short. I heard sound there for a second. We got some crackle through the speaker. So that tells us that at least the audio stage is working. Don't know about the rest of it yet. Bulb's getting a little brighter. So we do have some current draw here. But it seems to have stabilized, so that tells us that we don't have any scary leakage or anything that's going to cause a short or a failure. So I think what we'll do now is we'll get a bigger bulb. We're going to go up to a 200 watt now. I know, this is like illegal contraband in California. Incandescent bulbs, who would have thought? I do hear some hum through the speaker now. Definitely got some bad filters. The hum seems to be getting louder as we progress, so capacitors are dying. No surprise there. But the bulb is not getting any brighter. Let's do a quick test here and see if we have V voltage at our top cap connection for the horizontal out. That'll tell us that our main rectifiers are supplying some kind of power. And I assume that because this is a hot chassis that this is ground here. We got 85, 86 volts there. That's pretty low. Yeah, touching the probe to the horizontal out momentarily, the voltage does go up, but I'm not going to keep it there long enough to fry my meter. But we're not getting any brighter. It's pretty much just staying there at that kind of dim filament level, so we're probably drawing about 120 to 150 watts. But that hum you hear is open filters for sure. No static, no noise, nothing really above that. Start wiggling some tubes here. what I do here, hard to tell if it's the speaker or the yoke, but I hear what sounds like vertical deflection. What do you think? Should we attach the horizontal out and see if we have sweep yet? Kind of thinking we could. Let's just take an insulated object here. Yeah, I hear it like it's trying. All right, let's attach it totally, as we don't see any significant current draw. Watch the light bulb when I attach the horizontal output plate. Doesn't really go up, does it? Maybe a tiniest little bit. So we're not drawing on, I don't think we're getting any high voltage. Hard to tell. Anyways, let's reattach it and look at the front of the set. Alright, we got our top cap connected. Let's see if we get any kind of light on the screen. Definitely vertical. And when I adjust the vertical hold, the oscillator speed changes. But no high voltage that I can hear. Maybe let's bypass the lamp. Maybe we just don't have enough. Alright, here we go. No lamp, no nothing, just straight AC. Let's see what she does. I hear it squealing. Let's mess with our horizontal hold back here. Yeah, still no. Oh, we've got filter ripple here. So it's barely alive. So we have bad filters, of course. We barely have any brightness on it. It's trying to come alive, but so far it's not. But that's a good start. We've got something here. We've got some kind of raster. So that says that the chassis is capable of running, although the other one's in much better shape. So I think for the case of time and simplicity, we'll probably go with a better working chassis and restore that, since it's not a rust bucket inside. So anyways, I hope you guys have enjoyed this segment. When we get to part 2, we'll get to disassembling the parts unit and take the chassis and the tube out, since we'll be using it for this. Once you get that in place, or actually no point putting it in place until we recap the donor chassis and take care of all the ailments it has. But it powers up and has about an 80% screen raster, so figure once we get the power supply and stuff settled out, it'll be just fine. But it's a start. So anyways, hope you guys enjoyed watching this. More stuff to come.